So I'm going to go through a set of the core figures from the topic 3 of this synthesis report. Many of them focus on mitigation. And I'm going to give you a sense of some of the issues that come up when we think about reducing emissions. I'm not actually going to present here, except at the start when I read a conclusion, the specific conclusions, but I'm going to enter the material from a set of questions and then work my way through the figures. So first, let me just read you the core conclusion of topic 3. Adaptation, can you hear me? Okay. Adaptation and mitigation are complementary strategies for reducing and managing the risks of climate change.
Capitalism.
Adaptation and mitigation. Second, substantial emissions reductions over the next few decades can reduce risks in the 21st century and beyond, increase prospects for effective adaptation, reduce the costs and challenges of mitigation in the long run, and contribute to climate-resilient pathways for sustainable development. Later, in this same topic, we have the following phrase when we talk about pathways for mitigation that could keep us below 2 degrees. These pathways would require substantial emissions reductions over the next few decades and near-zero emissions of CO2 and other long-lived GHGs by the end of the century. Implementing such reductions poses substantial technological, economic, social, and institutional challenges, which increase with delays in mitigation. So with that, I'm going to use that as sort of an entry point to start working through the material. The first chart I want to show is one that you've now seen, you saw Dr. Pachari showed earlier. I'm not going to go through this in detail, but I would encourage you to look at this. This is a very synthetic chart. So it starts here with what you just saw from Petra, which is showing the reasons for concern. And this would be, you might think about that as working group 2. It then links through temperature to cumulative emissions. You might think about that as getting into the working group 1 terrain and potentially a little bit of working group 3. And then it links down to emissions reductions over the coming decades and what that entails, and that gets into the area of working group 3. And that's where I'm going to focus most of my discussion. Okay, so where are emissions concentration and temperature currently headed? Working Group 3 collected about 1,200 scenarios from integrated assessment models from around the world. Many of those, about 300, were reference scenarios. Those are scenarios without any additional mitigation efforts. And they come up with a range of concentrations in the long run, but none of them by themselves stabilize greenhouse gas concentrations or limit temperature increase. The temperature changes, actually I should step back and make one other comment before I go into that. One other note about this is these are not scenarios that are assuming we don't have technological change. These scenarios have a lot of technological change. And one of the major conclusions you get out of looking at this literature is that technology alone will not lead us to a stabilization of concentrations. You absolutely need to complement technology with policies to reduce emissions. So these are the concentrations, these are the emissions pathways that come out. What are the temperature changes? So as mentioned earlier, numbers like 4.8 degrees. So out of working group 3, when we look across all of these scenarios, we ran them through a simple climate model, which would be distinguished from the far more complicated Earth system models that are used in working group 1. We ran these through a simple climate model, but we then put a huge amount of uncertainty on the socioeconomic factors. And the range of temperatures we get for these is around 3.7 to 4.8 when we assume, I'm going to say, immediate sensitivity in the modeling runs that we did. If you include uncertainty, however, the range is substantially higher. For us, the range is somewhere from about 2.5 to almost 8 degrees. And there's differences in how to think about that. Working group 1 might end up with a slightly different range. But basically, we need to remember that when you hear these median estimates, something like 4.8, it could actually be much higher, and it could be much lower. So how much must emissions be reduced to limit temperature change to 2 degrees or other levels? Here are the emissions pathways leading to 3 degrees, and here are the emissions pathways leading to 2 degrees. This was shown earlier, and I'll go through in just a moment what some of the characteristics are of these pathways. But before I do that, I just wanted to make a quick comment about what do we mean by 2 degrees. There's several ways that we could think about what we mean by 2 degrees at a certain point in time, in a long-run equilibrium, What we've done here in this assessment largely is think about it in terms of the likelihood of staying below 2 degrees. But even there's different likelihoods, 50%, 60%, 70%, 80%. Largely, we're talking here about a likely chance of staying below 2 degrees, which roughly means 66%, a 2/3 chance of staying below 2 degrees over this century and then beyond. That's what these scenarios describe. Okay, so what does it require? So over the next 35 years, 2050 may seem like a long time from now, but it is in fact only 35 years from now. We're talking about reducing global emissions 40 to 70% over this period. We're talking about reducing them to or below zero in the second half of the century. And I might add that those scenarios that reduce it only 40% by 2050 require far more substantial reductions beyond 2050. I also want to step back and make one other comment about the baselines, which I think is important and pertains to how we think about these emissions reductions. The majority of the emissions that you see in those reference scenarios is not coming from the historical emitters. It's coming from economies that have been emerging over the last decades and will continue to emerge. And I think that's really important because it pertains to how we think about mitigation policy. Every country has a wide variety of different things it cares about, and capital is only one of them. And in many of these countries, growth, food security, energy access actually potentially take precedence over capitalism mitigation, and that's important to remember. Okay, next, how much does the energy system need to change? So this is largely an energy problem. It's an energy issue. How much do we need to change it? So let me show you a chart from the combined version is in the synthesis report. I'm going to go through it piece by piece. This is showing emissions by sector in baseline scenarios. And you can see the electricity sector has the highest emissions over time. That's a bit of a sleight of hand in a sense because other sectors, for example, buildings, use electricity. We're then attributing that here to the electricity sector as opposed to the building sector. There's actually two ways to account for emissions. One is to do it directly, where they actually happen. The other is to do it indirectly. This is showing direct emissions. So you can see building sector emissions are quite low. They're largely using electricity. Okay, so this isn't a reference scenario. Here's a mitigation scenario. This is a mitigation scenario that includes carbon capture and storage, carbon dioxide capture and storage. And I want to point out one key point here. So this is the electricity sector in 2050. And what you see is that largely emissions are reduced to or below zero by 2050 in these scenarios. So that's over the next 25 years. Just to make this clear, this is over the next 25 years. Assuming a wide range of economic growth, these scenarios are generally scenarios that assume somewhat of a happy world where growing economies continue to grow. We will, at the same time that the energy system is substantially increasing, we will be decreasing electricity emissions down to zero. This is without carbon dioxide capture and storage, roughly the same story. Okay, so you get a sense of how big, I hope, the scale of this challenge is. So one of the issues that's key on the table now, obviously, it was mentioned earlier, is how to think about upcoming negotiations. How do we think about where do we want to get as a global society, to the extent that we do work as a global society, over the next several decades so that we can stay on a path to stay below 2 degrees. So I'm going to take you through what is a bit of a complicated chart, but I'm going to work through it piece by piece because I think it actually tells a very nice story about how to think about this. And we're going to frame the concept of near-term emissions reductions around 2030. So let's say we got to one place in 2030, how hard would it be then to go forward? And I'm going to do it with a more ambitious near-term emissions mitigation and less ambitious. So let's just start. So we'll start. This shows a range of scenarios that lead to emissions mitigation, all of them below 50 gigatons by 2030. These are what we would call them immediate action scenarios. And they actually cover a wide range. The scenarios on the top assume a lot more technology in the future, and so they can go to negative emissions relatively easily. The scenarios on the bottom are probably assuming less technology. But you'll note that in this range here is where most of the scenarios lie. Okay, so they're reducing emissions. This is, I should add, these are cost-effective, immediate action scenarios. The world comes together very soon. We have a global carbon price. We're reducing emissions where it's cheapest, and we're trying to do it in a way that minimizes costs over time. In this case, we see a rate of emissions reductions between 2030 and 2050. These are the rates here, shown here. And basically, on average, most of them around, about half of them around in the 3% range. Those that have to do more between 2030 and 2050 are those that have the higher emissions in 2030 and vice versa. So you're talking about 3% emissions reductions from 2030 to 2050. In contrast, here are the historical emissions growth, maybe sometimes up as much as 3%. So we're talking about a dramatic change. Let's just remember that number, so 3% emissions reductions. In addition, we're talking about scaling up the percentage of low carbon energy by factors of, doubling, tripling. Actually, I should say this is showing here the share of low carbon energy. And from 2010 to 2050, we're talking about basically a doubling. And then, from 2030 to 2050. So this line here is 2010, if I can show you here. That's 2010, this is 2030, and then 2050. So we've already done some mitigation, put in some low carbon energy. This is actually the share of low carbon energy, but in a growing energy system, it's not just doubling. Maybe tripling, quadrupling. Some scenarios have it going up by 6 or 7-fold. Okay, now let's talk about doing delayed mitigation. This chart shows you the Cancun pledges. Right? You can see the dark bar where the Cancun pledges are. And then it sort of extrapolates those into the future. It says, let's say we got to about 55 gigatons or more in 2030. So we don't do too much. We kind of just follow this light trajectory up to 2030. What's that going to mean for the future? Okay, so our emissions reductions in the period from 2030 to 2050, we got to get them down. If we want to stay below 2 degrees and we've run up to above 55 gigatons by 2030, we got to get it down really fast. To get it down really fast, you're really basically doubling your rates of reduction that are required down towards 6%. That does pose substantial challenges, And in addition, because you have not done as much mitigation over the period to 2030, you have to increase your low carbon energy share of substantially more over that same transition period. The basic idea here is that by 2050 you have to reduced emissions substantially. The less you do over the next 15 years, the more you're going to have to catch up and catch up really fast. And so we hope in this report it gives a sense of what different targets over the next 15 years might imply for the feasibility of hitting long-term goals. Okay, so one of the big questions that always comes up, and in fact it came up earlier, is how much will it cost to reduce emissions? So there's a lot of different estimates of cost out there. I have heard in the past, there's obviously many sides to any argument, but on one side I've heard the statement that, well, we don't know what the damages of climate are going to be, but we know it's going to cost a lot. We don't actually. We don't know whether it's going to cost a lot or cost a little, to tell you the truth. So this is showing you reductions in let's just call it GDP. For economists, it's consumption, but over this period, it basically tracks relatively cleanly with GDP. And I'm going to give you the results of a range of studies that have looked at how much it would cost over the coming decades or over the century to reduce emissions for a 2-degree goal. But one thing I want to point out immediately is these are just the mitigation costs. So they don't take into account the benefits of reducing emissions. So there's a famous saying in this business, which is, there's no such thing as a free lunch, but it may be a lunch worth buying. And in this case, what's said here, this is only talking about the cost of that lunch. Okay? And it actually manifests itself in more than one way. One way it manifests itself is that we only look at this and we don't see, hey, well, we're going to get these benefits. The other is these are costs from a baseline that in some sense doesn't exist. because it's a baseline where we've done no mitigation, yet we haven't had any damages from
capitalism.
We don't even actually know exactly what that will look like. But let me just go ahead and go through it. So these are cost estimates. These are reductions, percent reductions in consumption in 2030, 2050, and 2100. And this is just showing the 16th to the 84th percentile, basically the middle two-thirds. And you can see the consumption loss is anywhere from about 4% up towards 12%, depending on the model. That's just the middle two-thirds. There's actually a range of different scenarios that have found lower costs or higher costs. I should also point out that these cost estimates are again based on this idea that we've done this as cost effectively as we can. We've implemented policies that allow us to reduce emissions where and when they would be least expensive. And that may not actually be the way things evolve. Okay, but we have gotten both higher and lower estimates under less idealized circumstances. There's actually one strain of literature that argues that if we undertake substantial mitigation, it'll solve a range of different market failures and distortions and actually put us at more economic growth. That's probably in the minority. The majority would get costs, and there's some that find substantially higher costs than these. But remember, these reductions, let's say it's 4%, again, 4% by 2100, that's against baseline economic growth. It's, something like 700%. So it's 4% lower than a very different world than we have today. It's not 4% lower than today. And there's always different goals with this material to present it as a high cost or a low cost. You can think about it either way. You can also present it in terms of the reduction in the growth rate, which was mentioned earlier. The median of the estimates here is 0.06 percentage points. That means if we were going to grow at 2% per year, we're going to grow at 1.94% per year. But it does add up by the end of the century, and there's both higher and lower estimates. There's estimates as high as 0.2 percentage points per year, and there's some that are down towards zero. Okay, so I find that a lot of the focus on the economic consequences of mitigation falls into this category where we're talking about what's the global effect. How much worse off are we going to be as a global society? And that definitely is important for thinking about mitigation. But in fact, I think what's also equally important to understand is that mitigation has very different effects for different countries, but also for different sectors. When we're thinking about action, this isn't just about all of us saying, oh, is it worth it? A lot of what this has to do with is who's affected and how. And so I want to go into two ways to think about that to finish this talk. The first is that substantial reductions in emissions would involve large changes in investment patterns. They'd also have large effects on assets, on fossil fuel assets. So fossil countries or people or sectors that have large fossil fuel assets, say oil in the ground, coal in the ground, gas in the ground, those are potentially devalued by climate change mitigation. That influences those sectors. This chart is showing you investment patterns, which is a little bit different, and it's showing the investment reductions or increases as you try and mitigate versus not mitigating over the coming decades. And what you can see is for total electricity generation, we invest more. For renewables, we invest more. And these are annual investments, and the units on the left are hundreds of billions of dollars per year. Renewables are more, nuclear is more, power plants with carbon capture and storage are more. But there's two that are going down. One of those is fossil fuel power plants without carbon capture and storage, and the other is the extraction of fossil fuels. So one of the key things we have to realize when we're talking about mitigation is that there are asymmetric effects on who's affected. And that, as much as what the total costs are, has a huge influence on our ability to undertake climate policy. On the converse side, I think I mentioned earlier that countries and people have very different priorities than
capitalist.
Frankly,
capitalist
just isn't on the top of everyone's list. Our hope is that we can put it higher on everyone's list, but it's not on the top of everyone's list. And so understanding the relationship between capital and other societal goals is critical for addressing, for taking action or for mitigation. So there's been a spate of recent work, and this is also material that's included in the synthesis report, looking at the interaction between
capitalism
and these other societal goals. This is showing the effects of mitigation on air pollution. It's been shown that there's very strong positive effects of mitigation on air pollution. I think you saw some very nice pictures earlier on haze in China. You can see that there are benefits to reducing coal consumption as a way to reduce air pollution, and it also provides a benefit. So a large emphasis now is on trying to understand these co-benefits and how to link up capital mitigation policy with these other societal objectives. And this is showing you here black carbon and sulfur dioxide emissions going down as a result of climate mitigation. Okay. And I'll just leave with this chart. The goal here is to show, I think this was a tremendous achievement and took an enormous amount of work to try and link across all three working groups and provide a synthetic understanding where you can go from the risks, cumulative emissions, down to emissions reductions that were required by 2050. So I'll close with that.